labeled for their by their section. Okay. All right. So jumping into section 3.5. All right, we're talking about polygons, and the first piece is, almost self-explanatory. Okay. As we have done up until this point, when you name a triangle or you name a line, right, you go in one direction. Okay, and so for example 1, you can see they started with M right here, right? So you've got M, K, H, D, B, G, okay? Or if you started with D, you could go D, H, K, boom, 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 right? It doesn't matter which way you go as long as you're naming it in an order, okay? Those are just two names. Now you could start with any point and go in a circle, okay? So naming these is simply just starting with a point like D and going in the circle D, H, K, M, G, B, okay? So that's how you name the polygon, is you start at a point and you go one direction. It doesn't matter which direction you go. When you name the sides of the polygon, you take the two letters between the side, right? So this would be BG, the segment with a line over it, okay? Very important. The angles are these things right here, right? This would be angle B. That would be the name of the angle, okay? So if you look down here at this polygon, the question is, name 3 polygons, okay? Rob, would you name one polygon for us in this picture? Right?
On the top one?
This picture right here?
Oh, A, B, C, D, E.
A, B, C, D, E. And can you tell us what type of polygon that is? You don't have to know just quite yet, but that's our next thing that we're going to learn. Do you know what type of polygon? How many sides?
Like a pentagon.
Very good. A, B, C, D, E is a pentagon. Right? Penta meaning 5. Pentagon. All right, very good. Nazari, would you name another polygon that you see in this image?
Perhaps a triangle.
Okay, so a triangle, and what's the name of it?
ABE.
Very good. Right, and there's several names for that triangle. It could be BEA, B-A-E, like Bay, right?
I just want to move it because Abraham Lincoln, for whatever reason.
All right, so Luigi, if you can, would you name the final polygon that we have?
There's 2 of them. There's a heptagon, B, D, H, K, and G. That one?
No. Down at this one right here. Okay, Rob named the pentagon, right? Rob did this one. Okay, Nazari did this one. Okay, there's one left. What is it?
Hexagon.
Not a hexagon. Heidi, could you name?
Pentagon.
What?
I said a pentagon.
Oh no, we got the pentagon, right? We got the pentagon. We got the triangle. We're missing one more polygon. Heidi, could you tell us what the final polygon is?
Which one are we? We're looking at the bottom one, right?
Yeah, we're looking at this one. So Rob did the pentagon. Nazari did this triangle. So what's left?
B, C, D, E.
Good, B, C, D, E. And you don't have to know, but what would you call that?
Would it be a square? like a rectangle?
Okay, so it doesn't have 90-degree angles, so this is actually difficult. It's called a quad for 4. Quad is 4. Quadrilateral, which just means 4 sides. Quadrilateral means sides. Quadrilateral means 4 sides. Again, you didn't have to know that, okay? But that's in our next. That's the next thing we're going to learn. All right. So we can find and name different polygons. All right. Here you have the different names of the polygons. Okay. In your book, you have this 3 triangle, right? For 3. Tri. Quad 4. Penta 5. Hexa 6. Octa 8. Nona 9. Deca 10. Dodeca is 12. And then you have an engon, which is any number that you say. Okay? Right? So, these are things that you should know. All right? Different polygons. Polygons are different from other shapes like rectangles and squares because they do not have right angles. For example, a square is a rectangle, but a rectangle is not a square. Okay? A square has 4 right angles and 4 equal sides. That's a square. A rectangle has 4 right angles and 2 pairs of equal sides. Okay? Now, that is different from a quadrilateral. Because a quadrilateral simply just has 4 sides. Now, pay very close attention because this is a little bit like Inception, right? We're going to go, there's layers to this. All right, so pay attention. A square is a rectangle because it has 4 right angles and it has 2 pairs of equal sides. Okay? But a rectangle is not a square. A rectangle is a quadrilateral because it has 4 sides. But a quadrilateral is not a rectangle because a quadrilateral doesn't have 4 right angles. Okay? So basically we're getting more and more specific. Okay? This would basically be like this. A human, then you might have a boy, and then you might have a boy with blonde hair. Something like that. I'm talking about Mr. Scrivener, right? Okay. Anyways, understand this. Does everybody who has blonde hair, are they all boys? No, that's not true. But this particular boy, this particular person, Mr. Scrivener, maybe it would be easier to do it like this. Right? Mr. Scrivener is a boy, but not all boys are Mr. Scrivener. Okay? So it works this way, but it doesn't always necessarily mean that all boys are Mr. Scrivener, right? Now, all boys, let's say, well, children boys, they're all humans. But not all humans are boys. So you see how it works one way as you go more specific, but it doesn't work the other way. Okay? So Mr. Scrivener is a human, but not all humans are Mr. Scrivener. Okay? It's the same way with polygons. Okay? So it's very important to understand the difference between a rectangle, a square, and a quadrilateral. All right? Now, continuing on. Finding a polygon's angle sum. All right? So you can see the polygon angle sum theorem right there. The sum of the measure of the angles of an n-gon is n minus 2 times 180. Okay, what does this mean? Okay, polygon, angle, sum, theorem. What does this say? It says the sum, okay, it means sum, okay? So the sum of the measure of the angles is equal to n minus 2 times 180, where n is the sides, the number of sides, sorry. All right, so let's go ahead and create a n-gon. All right, so you guys should be able to see this is a hexagon. It's got 6 sides, right? So if we go 6, right, n minus 2 times 180, 6 minus 2 times 180, 4 times 180 is 720. So a hexagon has 720 degrees inside of it, meaning all of these angles together equal 720 degrees. Now, I actually want to just take a quick moment, all right? I gotta grab a page. All right, here we go. All right, I want to take a quick moment to show you guys how we get this number, okay? Just so you guys can understand what's happening here, right? Okay, so here's our hexagon, and we said that 6 minus 2 times 180, 4 times 180 equals 720 degrees, right? How did we get that? Well, if we basically create triangles, right, to each one of these points, right, we know that here, this all the way around equals 360 degrees. Okay? So, again, each triangle has 180 degrees, right? So we say 180, 180, 180, 180, 180, 180, right? Each triangle is 180 degrees. Please don't get lost here. We did this yesterday. Each triangle, the triangle angle sum theorem says all the angles of a triangle equal 180. So we have 180 for each triangle, right? However, we are only trying to find these angles now. So we need to add all these 180s up and subtract what? 360, because the middle angles are not included. So basically, what is 360 divided by 180? And the answer is 2. And that 2 makes up this 2 right here. So we are subtracting 2 180s. So we have 6 triangles minus 360 is the same thing as 6 sides minus 2 triangles or 2 180s times 180. Right? That's basically what's happening. Okay? So we end up with 4 times 180, which is 720. Okay? Now, you don't have to know that. All you have to do is remember the formula, n minus 2 times 180. Okay? This is for an n-gon, right? Or a polygon. All right? You need to know that. This is the polygon angle sum theorem on page 159. Okay? Page 159. All right? and we will continue on. All right? So the first thing you need to know is how to name a polygon. Okay? Let's actually take a quick moment, and we are going to take this, something I should have done at the beginning of class, and I apologize for not doing so. All right? Put this at the beginning. And let's go ahead and just point out some of our objectives for today, what you guys got to know, right? 3-5 objectives. All right. Now your objectives are in the book. However, specifically, I'm going to simplify our objectives. All right. But in the book, you have 1 to classify polygons. Okay. What does that mean? Okay. The name of the polygon, the type of the polygon. Okay. And the no, that's the next one. So basically, in type breaks down to 2 pieces. Type is like concave versus convex, which we're about to do. Okay, and then also like the number of sides. Okay, so quadrilateral, etc., etc. Okay, so the second objective is to find the sums of the measure of the interior and exterior angle. Find the sums of the interior and exterior angles of any polygon. All right? So there's the 2 main things. Classify the polygon, the name, the type, and the number of sides. Secondly, to find the sums of the interior and exterior angles. Okay? Now, I want you guys to look at this image right here. Okay? So, very important that you understand the difference between a convex and a concave polygon. And I'm going to give you guys a very, very easy way to remember this. Okay? A very, very easy way. Do not forget this. Hopefully you're paying attention. Convex is, there's no diagonal that have a point outside of the polygon. What does that mean? If you draw a diagonal, which is from one point to another, at any point, any diagonal, it will not leave the polygon. Okay? Now, that seems kind of difficult, right? To remember all of that. What I do is I remember concave, and then whatever the other one is, convex. Concave has a cave, right? A cave inside the polygon. All right? Now, technically, what we're saying is that a line can be drawn between 2 points of the polygon, and the line will be outside of the polygon. That's a diagonal outside of the polygon. However, I just remember that it creates a cave. See, this is a cave. All right? So concave creates a cave, convex does not. And that is the simple difference between concave and convex. So first of all, we've got the name of the polygon, right? RADYT, or MPGQSWK. Both of these are polygons. However, this one is, then we have the second piece, which is how many sides does it have? This is a pentagon, right? This has 1, 2, 3, 4, 5, 6, 7 sides, so it would be a heptagon. Okay? Now, this right now, okay, is 2 different, we have 2 different names, right? We have the naming of it with the letters. We also have the type of polygon, like pentagon or heptagon. Then we have whether it's convex or concave. Those are the 3 different ways that we classify polygons, and that is our first objective. Done with that, okay? We've already moved into our second objective, which is understanding how to get the angle sum of polygons, all right? So here's the first piece. The sum of the angles is n minus 2 times 180. So for a hexagon is 6 minus 2 times 180, 4 times 180, which is 720. And we did a little explanation here. Okay, so here you have the sum of the angle measures, all right, before we get to the polygon angle sum theorem, okay? There's the polygon angle sum theorem that we just listed. Again, I told you these might be a little bit. All right, so the polygon, the number of sides, gives you the number of triangles formed, and then the sum of the interior angles of the measures, all right? That's basically what we did here, right? The number of triangles was 6, so the sum of the interior angles, that's these angles on the outside, right? Inside of the polygon, not counting the center, all right? The sum of them is 720, okay? Because we have to subtract 360 from the center, that means 60 basically from each triangle, all right? Which leaves 120 times 6, okay? 120 times 6 is 720. All right, continuing on, how does this work in the real world? All right, let's look at this question here. The game board at the right has a shape of a regular hexagon. It is packaged in a rectangular box outlined beneath it. The box uses 4 right triangles made of foam on its 4 corners. Find the measure of angle 1 in each foam triangle and find the measures of an angle of the hexagon first. Okay? So, a regular hexagon has 6 sides and 6 congruent angles. Again, very important to understand these terms that you see at the top of your picture. Okay? Sorry, let me just get there on mine, right? You have equilateral polygon, meaning the same length sides. An equiangular polygon, meaning the same angle for each one. And then you have, a regular polygon. That is a very important term to remember. All right. We want to go and we want to make a note of memorizing these terms. If you don't memorize the terms, you will not understand what they're telling you. They think that they're giving you information, but if you haven't memorized what these terms mean, that information means nothing to you. Okay? So, if you look here, of course, uploaded that one twice. Let's see if we can find. Okay, if you look on page 160, we're just going to have to write it because it looks like I don't have a picture for it. Okay? On page 160, you see the polygon, exterior, angle, sum, theorem. All right, and what does this mean? Well, if you have a hexagon, okay, the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So if we create an exterior angle like this, and you add 1, 2, 3, 4, 5, 6, you add all those angles up, 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals 360 degrees. Okay? The sum of all the angles of a regular polygon is exterior angles is 360. Okay? Now, moving on into the question that we were just doing with the real world problem, right? We need to first find the interior angles. The key is, this says it is in the question it says it is a regular hexagon, right? You need to know what that means. That means all the sides are the same and all the angles are the same. So we just did this. We just did the angle sum of a hexagon, right? We got 720. Now, if all the angles are the same, you can simply do 720 divided by 6, which is equal to 120. So each angle is 120. How do we know that? Because it's a regular hexagon. So all the angles are identical. They are the same. Okay? If you add all those up, you get 720. All right, so all those angles are the same. Excuse me. Now, that's important. Why is that important? Because there's several things that we can find out by induction. How do we find that out? Well, we know that this is a line, so angle 1 plus 120 equals 180. Therefore, angle 1 equals 60 degrees. Measure of angle 1 equals 60 degrees. All right, I hope you guys saw that. Again, here, 1 plus 120 is 180. Now, another kind of more complex way to do it would be to look here and say 2 plus angle 2 plus 120 equals 180. Take away 120 from both, and you're left with 2 times the measure of angle 2 equals 60. Divide both by 2, and you get the measure of angle 2 equals 30. Now, again, that was a little more complicated, but you could know that simply by saying this is 90 degrees, this is 60 degrees, 90 plus 60 is 150, so 2, the remainder, must be 30. Why? Because every triangle is 180. All right? Again, if you didn't memorize the theorem from yesterday that the sum of the angles in a triangle is 180, you're going to be falling behind. Okay? You've got to keep up with this. All right. Moving on. Here you have in the Jamboard, all right, you have questions from the book. More questions from the book. All right. There should be one more page of questions from the book, which would be page 161. 1 second. Here it is. 7. All right. So here you have questions, pages from your book, and you have the answers there. Okay? So you can look at your book or you can try these questions and then you have the answers to see. Okay? Now, let's go ahead and jump into one of these so that we can practice. Okay? First of all, is the figure a polygon? If not, tell why. Number 1, yes, 4 sides. Okay, number 2, no, because there's no sides. Number 3, no, because it's not in a single plane. It is in 4 different planes. Okay? 4, no. Why? Because 2 sides intersect between the endpoints. Okay? So you can see that this is no and this is no. All right? Number 5, name each polygon and then identify its sides and angles. All right, so this is kind of like a tedious task. I don't necessarily think that you guys need to, you just do one of these. You can do it in your head. If you get it right, wonderful. You can check your work here on the side or here at the bottom to see if you did it right. For example, here we have KCLP. All right, if you chose a different name like PKCL, you should know that that also works. All right? Now, the segments would be, KP, PL, LC, CK. All right? Those are the different segments. Then angle P, angle K, angle C, and angle L. All right? That being said, the name of the polygon, the type of the polygon, right? This is a quadrilateral because there's 4 sides. Okay? Naming the polygon, naming the segments, and naming the angles of the polygon. Great question because it asks so many in one, we don't have to waste time. All right, so down here, 16, 17, and 18, finding the missing angles of the inside of a polygon. Okay? I want you to pick one of them and try it. I'm going to give you 3 minutes to do so. Okay, go ahead and pick one and try it.
Do we have to write it in a notebook, or are you just going to ask us when you come back? Mr. Scribner, do we have to write this in a notebook, or are you just going to ask us verbally?
Neither. This is for your own benefit. All right, so looking at number 16, all right, the sum of the sides, 1, 2, 3, 4 sides, minus 2 would be 2, times 180 would be 360. So if you do 120 plus 85 is 205, plus 53 is 258. 258 plus 102 equals 360. So you do 360 minus 258, and you'd be left with the missing angle. These are not regular polygons. How do you know? Because the sides are not the same and the angles are not the same. Okay? The only way to solve something like this is if you have one remaining variable. Okay? Now, 21 is a great question. I'm going to do number 21 for you. Because even though you can only find one missing variable, it gives you 2 angles in relation to each other. Okay? So how can we do that? Well, we have how many sides? 1, 2, 3, 4, 5, 6 sides. Okay? So 6 sides. So 6 minus 2 times 180 would be 4 times 180. We already did this, would be 720. Okay? So 720 is equal to side n plus 6 plus 135 plus 62 plus 151 plus 140 And there it is. Okay? So if we add all the numbers together, right? 6, 135. Let's go ahead and add all those numbers together. 6 plus 135 plus 62 plus 151 plus 140. You get 494. So we get 720 equals 2n plus 494, right? Combine like terms, remove the parentheses, combine like terms, get all the numbers. So we subtract 494 from 720. 226. So we got 226 equals 2n, divide by 2, and you get n equals 113. Okay? So here you have n, right, which is 113. N plus 6 is going to be 113 plus 6, which is 119. Okay? All right, now down at the bottom here, because it's regular polygons, right, a dodecagon, like number 23, would be 12 sides minus 2 times 180, right? Times 180, which would be 10 times 180, which would be 1800 degrees for the whole polygon. Okay? But there's 12 sides, which means how many angles? Well, if you look here, 5 sides gives you 5 angles. 4 sides gives you 4 angles. So 12 sides gives you 12 angles. So 1800 divided by 12 gives you, 150? So 150 degrees for each angle. Then the question is, the exterior angles. What are the exterior angles, right? Well, if the interior angle is 150, all right, and together they make a straight line, okay? I need to create a new page to show you. So let's try and see if we can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's so hard to write 12 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, these are all supposed to be even, but if we said each one is 150 degrees, right? If you do here, right, the exterior angle, each one would be 30 degrees if it was perfectly even. Each one would be 30 degrees. Why is that? Because 150 plus 30 makes your straight line, which is 180. Okay? That's how you would find this number here, 30. Okay? All right. So that right there is section 3.5. Okay? If we just take a moment to go back to look at, take a moment to go back to remind us of our objectives, okay? Right? You got to be able to name it, right? Like A, B, C, D, E, okay? And you've got to be able to say whether it's concave or convex. And you got to be able to say whether it's a pentagon right, or a quadrilateral, right? Those are the different things that you've got to be able to do in terms of classifying polygons, okay? Secondly, you've got to be able to find the sums of the interior and exterior angles. Some things that we learned: equal, angular, right? Same angles. Equal lateral. Same side lengths. Regular. Both equal angular and equilateral. Okay? You should be able to find the sums of the interior and exterior angles. Okay? So, the sum of all the interior is n minus 2 times 180. Exterior is simply all of them add up to 360. Okay? So, if it was a regular polygon, you would do n minus 2 times 180 divided by the number of sides, and that would give you the angle for each. If you do exterior, you would do the 360 divided by the number of sides, and you would get the exterior angle. Okay? Very important to be able to classify polygons and to find the sums of their interior and exterior angles. Down the road, when we start making proofs, you're going to be required to know these theorems so that you can apply them. Okay? Do you have to memorize them word for word? No. You have to memorize the function of the theorems. Okay? We're going to take a moment to answer questions. If there's any question from the book that you would like me to answer, I will go ahead and do so. Okay? So it's open for questions. Any questions before I give you your questions that I want you to do as your exit ticket? Questions? Any questions? All right, we're going to stop the share